right, so far we've really only been talking about elements. We haven't talked about compounds and what the chemical formula tells us. We've only been dealing with atoms. So when we have a chemical formula, what it tells us is the number and types of atoms contained in 1 unit of the compound, which means if we have 1 mole of CCl2F2, then there is 1 mole of carbon atoms, 2 moles of chlorine atoms, and 2 moles of fluorine atoms in that compound. So our subscripts that are in the formula can actually be used to make conversion factors, to make mole ratios of atoms to whole compound units, molecules, or formula units. So let's look at a problem and see if we can figure out this mole ratio. So it tells us that aluminum oxide, which is Al2O3, often called alumina, is the principal raw material for the production of aluminum. Alumina occurs in the minerals corundum and bauxite. Determine the moles of aluminum ions in 1.25 moles of aluminum oxide. So, just like we've always done, we start with what we're given. Over 1. Okay. Now the question says, how many moles of aluminum ions do we have? Okay, well, now we look at our compound. So in the compound, in 1 mole of Al2O3, how many aluminum ions are there? Well, that's what the subscript tells us. There are 2 moles of aluminum ions in every 1 mole of the compound. So this cancels here. We multiply and we get 2.50 moles of aluminum ions. So our formula tells us what's called a mole ratio, moles of one thing to moles of the other. We get that ratio from the subscripts in the compound. All right, well, what if we want to know the molar mass of a compound? We've talked about molar masses of elements, and those come from the periodic table. But what if we want to know the molar mass of a compound? Well, we have to add up all of the masses of the elements that are in that compound. So, for example, if we want to find the molar mass of CCl2F2, then we need to add up the mass of 1 carbon, 2 chlorines, and 2 fluorines. So, look again at your periodic table. The mass of carbon is 12.011 grams per mole. And then we have 2 times the mass of chlorine, 35.453, and 2 times the mass of fluorine, 18.998. All right, so we add them all up. Now, molar masses are not measurements, they're conversion factors. So when you add them all up, you want to keep all the decimals that you have. We're not going to round our molar masses, we're going to use exactly what comes from the periodic table. So we add them all up and we get 120.913 grams per mole. Now, just like when we were working with the elements, the molar mass is now a conversion factor that we can use for this particular compound. So when you're doing these problems, finding the molar mass is going to have to be kind of a pre-step before you do the dimensional analysis. You're going to have to find the molar mass. You don't have to write it out like this. You can do it all in your calculator as long as you have this number available to use as a conversion factor in our problems. So for our next problem, we're going to have to find the molar mass of the compound to use as our conversion factor. So our compound is C3H52S. Okay, so the question says the characteristic odor of garlic is due to what's called allyl sulfide, which is C3H52S. What is the mass of 2.5 moles of this particular compound? So we're going to have to find the molar mass first and then use it as our conversion factor. So when you have a compound with parentheses, you have to distribute what's outside of the parentheses when you're finding molar mass. So really there's going to be 6 carbons and 10 hydrogens when we're adding them all up. So you're going to have to multiply the mass of carbon times 6 plus the mass of hydrogen times 10 plus the mass of sulfur to get the molar mass of the compound. Okay, so find that first, take a minute, add them all up, write it down off to the side so you have your conversion factor. Okay, now we want to start with what we're given, 2.50 moles of our compound over 1. And you just figured out our conversion factor. So we know that 114.214 grams per mole is the molar mass of the compound. So the moles cancel, we multiply, we round to have 3 sig figs, and our answer will be 286 grams. All right. Okay, so what if we know the mass but we want to find moles? Well, we can take our conversion, or our molar mass as our conversion factor, and we can just flip it upside down so that we want to cancel the grams, we want to end up with moles. Just like we've done before, you're just going to have to calculate that molar mass to begin with. All right, so let's do an example. Calcium hydroxide is used to remove sulfur dioxide from the exhaust gases emitted by power plants and for softening water by the elimination of calcium and magnesium ions. Calculate the number of moles of calcium hydroxide in 325 grams of the compound. All right, so we start with what we know, 325 grams of calcium hydroxide over 1. All right, so now our mole is going to go on top and our grams are going to go on the bottom, but we're going to have to find the grams. So what do we need to know about calcium hydroxide before we can find the molar mass? Well, we have to know what the formula is. So because this is ionic, we need to know the charge for a calcium ion, the charge for a hydroxide ion, and we have to put them together. So calcium has a charge of +2, hydroxide has a charge of -1, so we bond them together and we get CaOH2. Now we can find the molar mass because we know the correct formula. If you can't write that formula correctly, then your molar mass will be wrong and all of your calculations will be wrong. So again, just like I've told you over and over, you have to know your ions, you have to know how to put them together to figure out the correct formula. So when you look at the periodic table, you're going to add up calcium plus 2 times oxygen plus 2 times hydrogen. So take a minute, find the molar mass of calcium hydroxide, and then we're going to use it in our conversion factor here to convert from grams to moles. All right, so your molar mass is going to be 74.094 grams per mole. So our grams cancel, we divide. You want your answer to have 3 sig figs, so you round and get 4.39 moles of calcium hydroxide. And that would be your answer.